right. Today we are going to talk about operations with matrices. Okay? Yes, your calculator can do all of these things, but we need to know how to do these by hand. Okay? I will remind you that the quiz and the test will be split by a non-calculator and calculator section. Okay? So first of all, two matrices are equal if their corresponding entries are equal, which means they must also have the same order. Okay? We have the same order and each entry is equal. All right. Matrix addition. Okay, you notice how I have like this A and B? Just like your calculator, we're going to name matrices by capital letters. Okay? To add two matrices, first of all, they have to have the same order. If you're going to add two matrices, they need to have the same order. Okay. If you do not have the same order, we say that the sum is undefined. And how do you think we're going to add them together? Match up the numbers. Okay, the corresponding entries are going to be added. Whatever's in the first row, first column of A is going to be added to the first row, first column of B. It's going to be in the first row, first column of the matrix. The sum? The sum. When you add, your result is the sum. A plus B. A plus B. All right, and then scalar multiplication is just when we have, well, what's a scalar? Okay. It kind of acts like a coefficient, right? If we have a scalar, then we're just going to multiply it to each entry of the matrix. Right, are you ready for some examples? Write these down. Jason, what's the order of A? It's the order of B. Alright, so they have the same order, right? I want to find A plus B. So my sum is going to be a 3x3 matrix. Okay? My first row would be what? 4, 2, 4. 2 plus 2 is 4. 2 plus 0 is 2. 4 plus 0 is 4. Second row. 2. Right? Yeah. Okay. And then third row. When we get to multiplication. Okay? Now, if you wanted to add these two together, okay, you could put those numbers in a 3 by 3 matrix in matrix A, right? Put these numbers in a 3 by 3 matrix in matrix B, and you literally just pull up matrix A, hit the plus sign, pull up matrix B, hit equal, and it'll give you the sum of the two. Okay? Probably more work to check than you really want to do, but if you want to check your work, you can do that. Okay? Negative 2b. What happens when we have a scalar? Okay, every entry gets multiplied by the scalar. So in this case, we have negative 4, 0, 0. Alright. Now I want 3a minus b. Okay? That is exactly what I was going to suggest. I think we should do the scalar to a first and then worry about subtracting. So what would 3a be equivalent to? 6, 6, 12. Okay, negative 9. Should this be negative?
Yeah.
Okay, but everything else is okay? Okay. And then we're going to subtract b. Now you can choose to, multiply the scalar of negative 1 through and add them, or you can think of it as subtraction. I don't care what you do. Just be careful. 6 minus 2. 6 minus 0. 12 minus 0. Negative 9 minus 1. 0 minus negative 4. Negative 3 minus 3. 6 minus negative 1. 3 minus 3. 6 minus 2. Yes. Be very, very careful with your arithmetic. Now, I can be pretty forgiving if you have everything right except one little entry. Okay? Be careful. You don't want to go too fast and make lots of silly mistakes. Okay? So Carl asks, this can't be all we're doing. This is way too easy. We're going to multiply. Okay? First of all, if A is m by n and B is n by p, then we can multiply them and our result, our product, will have an order of m by p. Okay, what is it? All right. Our order. A has to be m by n and B has to be n by p, which means the number of columns in the first matrix must match the number of rows in the second matrix. They have to match in order for you to be able to multiply. Our result is m by p. So those two that were matching, what's on the outside, that's your new order. yes and yes. Or if you
Multiplication, like switching around.
Ooh. We're going to talk about if it's commutative or not. That's what you're asking, right? Okay. It is not going to be commutative. Okay, so matrix multiplication is row by column multiplication. Okay, where we're going to take a row by a column and we're going to multiply the entries and add them together. And whatever row we multiply to whatever column, that's the new place that number gets in the product matrix. Okay, nothing I'm saying really makes sense probably right now. All right, this is one of those things that we just have to do. Okay, to figure out what's going on. Okay, so you can write this down if you want to. All right, or as we go through the process of multiplying, maybe you can make some notes to yourself that make more sense than this paragraph. Okay. Okay. So what this means, I am going to take the first row and I'm going to multiply it to the first column, and that number I get is going to be in the first row, first column of my matrix. Okay, so the reason we have to have the same number of columns as rows is because we're going to take these numbers and we're going to multiply them to this column. The numbers in this row get multiplied to the numbers in this column. Okay, so we're going to take negative 1 times negative 3 and 3 times negative 4 right there. And that is our one entry. Okay, then I'm going to move. I'm going to take the first row and I'm going to multiply it to the second column, and that value goes in the first row, second column of my new matrix. So I take these two numbers and we match them up here and we multiply. Negative 1 times 2 plus 3 times 1.
So that's why the that's why the row has to match the column.
That is why the row has, that's why the number of columns here need to match the number of rows here, so we have numbers matching up with each other to multiply.
So you basically just like whatever, you just multiply the whole first row and first column that equals the second row.
Yes. Yes. Then if we move to the second row times the first column, that number is going to go in the second row, first column. Okay, we're going to take 4 times negative 3 and negative 2 times negative 4, add that together, and that is our entry. Second row times second column, we match these two numbers up, multiply and add them together. Okay, and that goes in the second row, second column of our matrix. Okay. That's what they meant by the iceberg column. Okay. And then we just keep moving down our row until we get to the end. Now I'm on the third row, so I can multiply it by the first column. So 5 times negative 3, 0 times negative 4. That goes in the third row, first column. And then finally the third row, second column. Okay, this is my last entry because I put the last row in the last column.
So you just like FOIL like first row, second row.
Yeah, we're distributing each row to each column, right? Okay, so then we're actually going to, multiply and add the numbers together, right? So this becomes 9, negative 9. This becomes 1. My second row, first column becomes negative 4, 6, negative 15, 10.
So you can only do it if it's the same number of rows by column. So if there's 2 rows, and it has to have 2 columns.
The number of columns in the first matrix must match the number of rows in the second matrix. Kind of like what I've written up here, Chase. Yeah, use that to match. it. I mean, really, matrix multiplication is the hardest thing to do by hand. Okay? A lot of room for error. Okay? We're going to find this product. First of all, Carl, what's the order of A? 2 by 3. Now, what's the order of B? 3 by 2. Can we multiply these together? Yes. Our product is going to have what order? 2 by 2. So that's what's going to be left over. Okay? Okay. So, okay. First row, first column. We get, what is 1 times negative 2? Oh. Plus 0 times 1.
0.
Plus 3 times negative 1. Okay? That is 1 entry. Okay? Then we're going to go first row, second.
Oh, this is mean.
First row, second column. Okay? And we're going to match these 3 numbers up over here. So we have 1 and 4. Plus 0 and 0. Plus 3 and 1. And that is our first row, second column. Okay? Then we're, okay. Now we have second row, first column. And that's going here. Second row, first column. What is 2 times negative 2? Negative 1 and 1. And negative 2 and negative 1. Okay, those are 1 and 3. And then finally we can take second row, second column. We're going to match 2 and 4. Negative 1 and 0. Negative 2 and 1. Okay. So our 2 by 2 matrix is negative 5, 7, negative 3, 6. Alright? I want you to check our work in your calculator. Please enter a 2 by 3 matrix, this 2 by 3 matrix in for A, this 3 by 2 matrix in for B, and then take matrix A times matrix B in your calculator. Yes. Noah, would you like to go back and look on your calculator? Yep. Yeah, here I'll erase this.
Woo, that's awesome. Good work. He helps ours. Miss Lena.
That's cool.
Alright, are we getting this?
Okay. Kyle, you gotta write your name on it. Where's your name?
Okay.
All right. You get it on your calculator?
Yeah.
Okay. Is matrix multiplication commutative?
No.
Okay, let's think about in this example, what if we took B times A? What would the order be of B times A? What?
3 by 3.
It would be a 3 by 3, wouldn't it?
Yeah.
Because B is 3 by 2 and A is 2 by 3, and so these match, and so we would have a 3 by 3 matrix, okay? We want to get the same thing if we take A times B and B times A. Sometimes we can take A times B, but we can't even take B times A. Alright? If you have a 2 by 7 matrix for A and a 7 by 3 matrix for B, you can take A times B, but B times A would be undefined. Okay? So, here's a case where multiplication is not commutative. Okay? It's commutative for real numbers, but not for matrices. Okay? Alright, I'm going to put you to the test.
What? Do that. That's 0. 0 is always confusing. There we go.
I want you to do this by hand. Now.
And then we multiply by this thing?
Yes. Parentheses first, right? So multiply the two together. Also, it'd be easier to multiply those numbers if they're smaller, right? Okay? So I would like you to do this multiplication and then multiply by that -3 afterwards.
Alright.
Okay, so for the people watching at home, what was our answer?
27, -6. -6, -27.
Is that right?
Yep.
All right. Check in your calculator and it should be good. All right, last problem.
Oh, no.
All right, 2 softball teams submit equipment lists. Each bat costs $80, each ball $6, and each glove costs $60. Bats are expensive, people. That's, yeah. This is an old problem, probably. Okay. What is the total cost of equipment for each team? Look, we already have a matrix right now, don't we? Okay. We have a matrix 12, 15, 45, 38, 15, 17. Okay, and this stands for women's. Notice how they're first. Men's. Bats.
Oh, that was funny.
Balls. Gloves. I'm just kidding. Okay.
Oh, I said she was a woman. I was like,
Thank you. All right, now, okay, if I'm going to figure out the total cost of something, what do?
well,
We multiply how much things cost by how many you have and then add them together, right?
yeah.
Isn't that what we do with matrix multiplication? I think it is. Okay. So, the second matrix we're going to have is going to have how many entries? 3. Do we want a 1 by 3 or a 3 by 1 matrix? Okay. This is a 3 by 2.
1 by 3. 1 by 3.
by 3 so that the 3s can match up with each other, right? Okay. So we have bats cost $80. Balls cost
Oh, and they match up with each other. That's so clever.
how much? And Noah, light bulb just went on. These match with these.
Oh
the
my
label.
gosh.
Okay. So when we multiply,
Wow, Noah.
That's weird.
we're gonna get a 1 by 2 matrix with money
Funny how math works.
for each team.
Wow.
Okay, so help me out. What is 80 times 12 plus 6 times 45 plus 60 times 15?
I know the fuckers want to
Oh, it's so big effort.
2,130. Why did you do that there?
Okay? 80 times 15, 6 times 38, 60 times 17. Of course. They're more high maintenance than men. Okay, so the women's team, it's going to cost them $2,130 to play. And the men, it's going to cost them $2,448 to play.
Honestly, who needs 15 bats in a season for a team?
You may not like that break on the back.
Okay? So, here, matrices applied to real life. You love it, right?
Add 12 plus 15 times.
Isn't that what we did?
I know, but like, why would you?
It's just an organized way to do it. What if you have a lot of values? Okay.
And you can do it on your calculator.
Good. Now, here's the thing about your homework. All of these will be done by hand, and then you can check using your calculator.
Oh, okay.
I like that.
You need to be able to add, well, obviously, I'm pretty sure you're going to be able to add without your calculator. But you need to be able to multiply matrices without your calculator for the test and the quiz. So just
Are they going to be like numbers like 3 times 6, or are they going to be like 45 times 27?
you're going to be able to multiply them and add the products together
Okay.
just fine.
I'm just making sure.